AI. It's on everyone's lips now, and it's going to be on everyone's lips for years, if not decades to come. But where does this technology that allows for cool chatbots that know everything, self-driving cars, websites that can generate the most beautiful girl you've ever seen in your life come from? The ancient Greeks had a knack for storytelling, weaving tales of heroes, gods, and fantastical creatures that captured the imaginations of generations to come. But amidst the tales of mythical beings and epic battles, there are also hints of something more familiar to our modern world. You guessed it, AI. One such example is Talos, the giant made of bronze who stood as the guardian of Crete. He was not just a statue, but a machine designed to defend the island from invaders. Talos was created by the god of fire and craftsmanship, Hephaestus, with the help of a cyclops. According to legend, he would patrol the island's perimeter 3 times a day, throwing boulders at any ships that dared approach. This image of a metallic sentinel tirelessly patrolling its territory is eerily similar to the drones and robots we see today, but like many AI creations, Talos was not invincible. In the story of the Argonauts, Jason and his crew defeat the giant by finding a single plug near his foot. Once removed, the vital fluid known as ichor flowed out of his body, leaving him inanimate. This is a classic example of the off-switch problem that has plagued AI designers for decades: how to safely shut down a machine that has become too powerful or dangerous. Another example of AI in ancient Greek mythology is the story of Pygmalion. This legendary king and sculptor was said to have created a statue of a woman so beautiful and lifelike that he fell in love with her. This tale predates the idea of AI as we know it, but it speaks to the human desire to create something that is both beautiful and intelligent. Pygmalion's story also touches on a common theme in modern AI research: the idea of creating machines that can think and learn like humans. In the story, Pygmalion prays to Aphrodite, the goddess of love, to bring his statue to life, and in a miraculous turn of events, the statue comes to life and becomes his beloved wife. This idea of imbuing machines with human-like qualities and emotions is at the heart of many contemporary AI projects. So, while the ancient Greeks may not have had the same technology or terminology that we do today, their stories hint at a fascination with the idea of creating artificial beings that can think, learn, and even love. Whether it was Talos, the bronze guardian of Crete, or Pygmalion's statue coming to life, these stories show that the dream of creating intelligent machines is one that has persisted throughout the ages. What we may have soon was imagined by generations of people before us. Many people may think that the concept of automata is a relatively modern development, but the truth is that these devices have been around for centuries, and these devices were the precursor of modern-day automated machines. In fact, automated devices proliferated in the medieval Islamic world. The mid-8th century saw the first wind-powered automata being built, in the form of statues that turned with the wind over the domes of the four gates and the palace complex of the round city of Baghdad. These wind-powered statues were a public spectacle, but they also had their private counterparts in the Abbasid palaces, where automata of various types were predominantly displayed. Moreover, in the 8th century, the Muslim alchemist Jabir ibn Hayyan Geber included recipes for constructing artificial snakes, scorpions, and humans that would be subject to their creator's control in his coded Book of Stones. Such advancements continued, and in 827, the Abbasid Caliph al-Mamun had a silver and golden tree in his palace in Baghdad, which had the features of an automatic machine. The tree had metal birds that sang automatically on the swinging branches, built by medieval Abbasid inventors and engineers. In the 9th century, the Banu Musa brothers invented a programmable automatic flute player and described it in their Book of Ingenious Devices. But it was Al-Jazari who made a significant impact in this field. He described complex programmable humanoid automata, amongst other machines he designed and constructed, in the book In Knowledge of Engineering Tricks in 1206. One of his most famous devices was a boat with 4 automatic musicians that floated on a lake to entertain guests at royal drinking parties. The mechanism had a programmable drum machine with pegs, cams, that bumped into little levers to operate the percussion. The drummer could be made to play different rhythms and drum patterns if the pegs were moved around. Al-Jazari's legacy also included an enormous water clock, featuring an elephant carrying his driver and a tower filled with creatures. Simple water clocks had been used in ancient Egypt and Babylonia, but Al-Jazari's intricate invention clearly expressed his ambition to perfect them. Medieval Muslim engineering was a springboard for the development of automation, and attempts to bestow upon machines or non-sentient entities the ability to perform human tasks autonomously autonomously, which is the ultimate goal for AI itself. It is for this reason that Al-Jazari is now considered the father of robotics. But the story behind the development of AI does not end there. In fact, it has only just begun. The foundations of artificial intelligence are grounded in computer science, and computer science owes itself to formal logic, a journey that spans centuries and the minds of some of the greatest thinkers of all time. In the mid-19th century, a young mathematician named George Boole stumbled upon an idea that would change the course of computing forever. Boole's contribution to the field was his development of Boolean logic, a system of mathematical reasoning that uses only two values, 0 and 1, to represent true and false statements. Boole's system of algebraic logic allowed for the manipulation of logical statements using binary variables and operations such as and or. These operations are the building blocks of modern computer programming and are used in virtually all digital devices. Another significant development in formal logic during this period was the work of Gottlob Frege. Frege developed a system of predicate logic that greatly expanded the range of logical operations that could be performed. His work allowed for the formalization of complex mathematical concepts and played a key role in the development of modern set theory, which is essential to computer science. The work of Boole and Frege eventually led to the development of modern mathematical logic, which was foundational to the emergence of computer science, primarily thanks to algorithms. An algorithm is a step-by-step procedure for solving a problem, and it can be expressed in a formal language such as a computer programming language. The ability to express algorithms in a precise and unambiguous way is essential to computer science, and it is closely related to the use of formal logic. We credit Alan Turing with the invention of computer science. Turing is best known for developing the concept of a universal Turing machine, which is a hypothetical machine that can perform any computation that can be expressed as an algorithm. The concept of a universal Turing machine provided a theoretical foundation for the development of digital computers, which are based on the idea of executing algorithms encoded in binary code. Turing's work on the foundations of computer science was closely related to his interest in formal logic. In particular, he was interested in the question of whether there could be an algorithmic procedure for determining the truth or falsehood of any mathematical statement. This question, known as the Entscheidungsproblem, had been posed by David Hilbert in the early 20th century, and it was a central problem in the philosophy of mathematics. Turing's solution to the Entscheidungsproblem was based on the concept of a Turing machine. He showed that there was no algorithmic procedure that could determine the truth or falsehood of all mathematical statements, but that there were specific problems that could be solved algorithmically. This idea laid the foundation for the development of computability theory, which is concerned with the study of what can and cannot be computed algorithmically. In the early 20th century, science fiction writers dazzled the world with fantastical tales of intelligent robots. Yet it was not until the 1950s that the concept of artificial intelligence began to take root in the minds of scientists, mathematicians, and philosophers. One such visionary was Alan Turing. Yes, it's the same guy from earlier, who contemplated the mathematical possibility of AI. Turing posited that if humans could utilize available information and reasoning to solve problems and make decisions, why couldn't machines do the same? This was the logical framework of his groundbreaking 1950 paper, Computing Machinery and Intelligence. 5 years later, Alan Newell, Cliff Shaw, and Herbert Simon initiated the proof of concept with the creation of Logic Theorist, a program designed to mimic human problem-solving skills. However, there was one significant obstacle. Computers lacked the computational power to execute anything substantial. They could not store enough information or process it quickly enough to perform at human-like levels. The formal birth of AI occurred in 1956 at the Dartmouth Workshop, organized by Marvin Minsky, John McCarthy, and two senior scientists, Claude Shannon and Nathan Rochester of IBM. The conference proposal proclaimed, "Every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it." The attendees included Ray Solomonoff, Oliver Selfridge, Trenchard Moore, Arthur Samuel, Alan Newell, and Herbert A. Simon. It was a momentous occasion that heralded the arrival of AI in the world of science and technology. The first chatbot, Eliza, and the first intelligent robot, Wabot, soon followed. However, progress in the field of AI was erratic, characterized by periods of dormancy and sudden bursts of research funding. It was not until the big data era and the explosion of information that deep learning, data science, and big data facilitated a resurgence in AI research. With the vast amount of data generated by individuals and organizations alike, AI had had the ability to learn and adapt at an unprecedented pace. The availability of data has allowed machine learning algorithms to be trained on large data sets, enabling AI systems to identify patterns and make predictions with greater accuracy. Machine learning is the backbone of modern AI, and it relies on large data sets to make sense of complex information. These data sets provide the algorithms with the necessary information to learn and improve over time. As more data becomes available, machine learning algorithms become more sophisticated, allowing AI systems to perform complex tasks such as image recognition, natural language processing, and even decision-making. These breakthroughs are opening the gates to a new era of possibilities, and today, AI is poised to revolutionize every aspect of human life. The latest breakthrough in AI was OpenAI's ChatGPT, which ushered an AI race between the biggest companies in the world, which brings us to the present state of AI. If you want to learn more about the deep implications of artificial intelligence on our society, don't forget to subscribe to our channel.